Hello, grade 12. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabutewa Sos Ugobela Maths. And without any further ado, let's look at these questions that we have here. Okay, so question 6 says in the diagram below, the graph of f of x is equals to tan x and g of x is equals to 2 sine 2x are drawn for the interval x element of negative 180 degrees all the way to positive 180 degrees. Now A, which has the coordinate 60 degrees to K, as we can see here, and B are 2 points of intersections of F and G. So as we can clearly see here, that B is a point of intersection and A is also a point of intersection as well. Then 6.1, we are told to write down the period of G. Now, this is what you need to note about the period. The original graph or the format of the format of these equations are A sine bx plus q, or it could be cos, it could be tan here. Now, you need to understand the effect of the B here, which is the number in between the trig ratio and the x there. Now, the effect of this B here is actually to either increase the period by doubling it, tripling it, or halving the period. So this is one thing that you need to understand about the period of sine and cos. The period of sine and cos, originally the mother graphs sine x and cos x, are 360 degrees. Now, if you have a number in here, this affects your period. So this is what you essentially do to find your period, your new period. So this becomes period is equals to 360 divided by the number that you will have in this position there. So suppose that the number in there, as we are given here, is 2. That means what we are supposed to say is the period is equals to 360 divided by 2. Then if we say 360 divided by 2, that's going to give us 180 degrees. So that means our period for this graph is 180 degrees. So basically, to find the period for sine and cos, you just simply say 360 divided by whatever number that you are given here. But that is not the same case for tan x, hence you did not see me writing it there. Now, the original mother graph for tan x is a period of 180 degrees. So that means if you had 2 tan 2x, for example, then you'd say the period is actually 180 degrees divided by the number that you will have there in the position of B. So that means this is not applicable. The 360 is not applicable for tan, mainly because tan has a period of 180 degrees. So be careful with tan, but then if you are working with sine and cos, then you just simply say 360 divided by whatever number there. So, and another example would be, let's say you are given sine half x. Sometimes you are given this. How would you determine the period? Simple, you just say your period is 360 divided by half, which your half can be 0.5, can be written as 0.5. And then therefore, if you decide to just add a smaller number here, then that means what happens to your period? Your period increases or enlarges, right? So this simply means that your graph will now be wider, right? In terms of what it covers in your domain, right? Okay, so 6.2.1 says, let's calculate the value of K. And then if we can locate K, we can see that it is in point A, which we were told that A is a point of intersection. So that means we can calculate the coordinate there, our Y value, by either using the graph of F or the graph of G, since A there is a point of intersection between the two graphs. So we can just go ahead and use f of x and then just say f of x is equals to tan x. So that means where there is x, we can just simply substitute our x value there. That's tan 60 degrees. Then our f of x, we know that that is the same as writing y, which will just give us root 3, right? So the value of k in that case is root 3, because we are given that k here is a y value. So that means k is equals to root 3. Right. Then now they're saying 6.2.2, calculate the coordinates of B. So at the position where B is, we can clearly see that this is the same position where A is in terms of your vertical coordinate, right? Or in terms of your y values, right? So that means the y value of B there is also root 3. So we don't have the x value. But then there's something interesting if you can just look at the intercept here, the x-intercept to be more specific, versus that point of intersection. We can see that there is a distance of 30 degrees there in between the point of intersection and the intercept. So if we can have our 60 there and then going to the intercept, we can see that there is a distance here of 30 degrees. So which means the same thing will be done over to this point, right? If we have negative 90 degrees here, since now we are going to the left, that means we have to shift 30 degrees to the left. So this is just a matter of observing your graph, right? This comes from just observing your graph. If we shift 30 degrees to the left, then we end up with negative 120 degrees, right? Which can be essentially calculated by simply taking, we can also take the 60 degrees there, and then since it is found in this second quadrant, but then in the negative axis, we can just say 60 minus 180 degrees, and then that also as well gives us negative 120 degrees, right? So you can use your observation of the graph, or you can use the point of the quadrants there. Okay, so now let's go to 6.3. 6.3 says write down the range of 2 times gx, right? Now you have to be very smart in answering the question. Note that we have a g of x here, which is 2 sine 2x. And then if we were to determine the range of the original graph first, what will be the range of g of x? Now we do know the effect of the a here. This increases the amplitude, right? So the mother graph has an amplitude of 1, right? Or simply that makes it to have a range of -1 to +1. But now that we chose to put the 2 in here, that means our range will be y, element of -2 to +2. So that means the minimum value of this graph here that you are seeing is -2. And the maximum value is +2. Now note that the 2 times gx simply means that we are increasing the graph of g by a scale factor of 2. So what do I mean by that? This is 2 multiplied by the equation of g of x, which is 2 sine 2x. Note that the 2 here can only multiply with the coefficient, not with this 2 here. So make sure you don't make that mistake. So the 2 times 2 only, we only get the 4 sine 2x, right? So nothing is being done to this 2x here because this is simply the angle. Now, if we have our equation as 4 sine 2x, and then we saw what the 2 did here, the 2 made our range to be -2 is to 2. So if we have 4, it is obvious that our new range now will be what? Y, element of, so just this -2 multiplied by 2, that's -4, and then +2 multiplied by 2, that's +4. So that means our new range now is -4 to +4, right? So it's just a matter of understanding that they increase the graph of g by a scale factor of 2, which will then impact our range. So basically, if I were to show you what happened here, this is what happened, guys, with that graph. This is what happened with that graph. Let me show you. Just quick. So basically, when the amplitude increases, this is what you have. It does not affect your intercept. So you see the positions of the intercept are still right in that position. So it's still intercept with the axis, where it intercept with the axis, right? So, but then all that is being done there is to increase the amplitude of the graph. So we had positive 2 here, but now we end up having positive 4 for the one that we increased amplitude on. So this is negative 4, and then this here is negative 2. So now you do understand where we got this range. So our minimum value, remember the range is the minimum value to the maximum value, a set of all possible y values. So it's starting from the minimum value, negative 4, all the way to our maximum value, which is positive 4. And that's how we get the range of this graph here. Okay, then let's look at 6.4. So 6.4 is saying for which values of x will g of x that has been shifted 5 units to the left minus f of x that has been shifted also 5 units to the left be less than or equal to 0. Now, why am I saying to the left? Remember, we've covered this in functions to say that if they say x plus, that indicates a translation to the left-hand side, and then this is left. So it is being shifted the same way, right? So the graph of G and the graph of F are all being shifted 5 units to the left. Now, this is how we answer these questions. The first thing that you want to do is you want to write this in a way that is in a way that we can interpret this, right? In a way that we can understand. So this is 6.4. We are going to say g of x plus 5 degrees, and then we can just choose to transpose this, right? So we're going to say less than or equal to f of x plus 5 degrees. Now, what is the meaning of this? Suppose we had no 5 there. Suppose this was not shifted. We only had g of x less than and less than or equal to f of x. What this would mean is that where is the graph of G either below or equal to the graph of G? The graph of F, not G. Sorry for that. So it would essentially mean where is the graph of G either below or equal to the graph of F. So that is the interpretation of what we have here, right? So suppose we only have this. This is where the graph of G is either below the graph of F or at the same position with the graph of F. Now, if we were to locate that, let's highlight our graph of F as the red graph here. And then let's highlight the graph of G as the green graph, like that. So I'm not going to do everything because remember, our interval, we are only told to only look between negative 90 to 0. So pay also attention to the restriction. So note that it said in the interval, x element of negative 90 to 0 degrees. So that means we are only looking for solutions in this part here, right? Okay, so suppose we were just answering this question here. We would say, where is the graph of G either below or equal to the graph of F? Now we can clearly see that we located just in between here, just between these points of intersection, because we can see the graph of F is the red graph, and then the graph of G is the green graph. So this is where the graph of G is below the graph of F. Now note that in between 0 to 90, this is where we find the green graph being below the red graph. At this point, going to that position, we can see that it is the green graph being above the red graph, which is not what we are looking for. We are looking for the red graph being above the green graph, right? So this is what we have here. But then we have a challenge of finding this point of intersection. What's that point of intersection? Remember in the previous question in 6.2.2, when we are finding the coordinates here, we said the coordinates of B were negative 120 degrees to root 3, right? So these were the coordinates of B. And then here we had negative 120 degrees. And then we found that the relationship that the intercept the intercept have with the point of intersection is that they are always 30 degrees apart, right? So the intercepts are 30 degrees apart with the x-intercepts, right? So this is it. Meaning at this point, we can find that this is actually negative 60 degrees. So if we're answering this one, we would say this is when x is an element of negative 60 degrees included, and then all the way to 0 degrees included. Because these are the points where the graphs are at the same position, but then after 60 degrees, all the y values, we find that the graph of f is above the graph of g. Up until this point, again, where they are at the same position. And then after that point, we can see that the one that becomes above is the graph of g, right? So this would be the solution if we were answering this one. But now the catch is they chose to shift these two graphs 5 units to the left, which means this will affect our solution right now. So now if we shift this is more like shifting these points also 5 units to the left. So that means our new solution, remember, we are not changing the graph. We are simply taking this same graph and then we are shifting it 5 units to the left. Meaning if we take from negative 60, we shift 5 units to the left, we now have negative 65 degrees. If we take 0, we shift it 5 units to the left, now we have negative 5 degrees. So this is the solution that we ought to have in 6.4. So I hope it makes sense. Take your time to try to understand the approach that I took in solving that one. Okay, then let's now proceed to 6.5. So in 6.5, it says determine the value of p for which sine x cos x is equals to p will have exactly 2 real roots in the interval x element of negative 180 degrees to 180 degrees, right? So now we are given 6.5, that's sine x cos x is equals to p. But then one thing that you must always note when it comes to trig functions is that they will never give you anything that is not one of this, right? So they will always try to play around what they've already given you. Now, if we can check, where are we going to get the sine x cos x? Looking at this one, we can see this is a double angle identity from grade 12, which we know that from doing that one, that's where we actually have the sine x and the cos x. So now we have 2 sine x and then 2x. Now, what we can do here is let's try to break this one down so that we see what's going on. So if we can say 2 outside, and then let's break this double angle because the double angle identity is only this part here. So this breaks down to 2 sine x cos x according to the formula sheet. And then this is 2 multiplied by 2, which is 4 sine x cos x. Now, if we want to recreate this from what we are given here, then it's simple. What we need to do here is simply just multiply by 4 both sides, right? So we want to take the left-hand side multiplied by 4, the right-hand side multiplied by 4, right? And then we end up with 4 sine x cos x, and then that is equals to 4p. Now that we've recreated this, we can write this in the original formula, which is g of x, right? So this will be 2 sine x, and then is equals to 4p, right? So now we can solve this using the graph, because we have found a way to actually express this in terms of what we are given here. So they're saying determine the value of p for which this will have exactly 2 real roots, right? Note that we concluded that the range of the graph of g here is actually y element of -2 to +2. So that means this graph can either have its lowest value being -2 or its maximum value being +2. Nothing below that, nothing beyond that. So we can use that to say, okay, this is 4p, since the 4p now stands for g of x, right? So the whole 4p is now the graph of gx, right? But now we know the graph of gx has a maximum value of -2, a minimum value of -2, and a maximum value of +2, which means to find our values for p, we can say 4p is equals to -2, or 4p should be equals to +2. Remember, we are trying to find the values of p. So we can just go ahead and divide by 4 here. And then now our p becomes -1/2, or p is equals to 1/2. So that means in respect to sine x cos x, the values of p for which we will have real roots occurring from this equation, it's only if our p is -1/2 or if it is +1/2. So make sure you also take time to understand the approach that I took in solving this one. But then, okay, we have reached the end of the lesson. With all that being said, please press the thumbs up button and hit that subscribe button if you've been watching and haven't subscribed yet. And if you are watching these videos from Facebook, please like the page and follow the page. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.